So today we're going to cover Chapter 5, Section 7. Today we're going to be using congruent triangles. So what you're going to need to do first is prove the two triangles are congruent using one of the 5 shortcuts that we covered in the earlier lessons. Once we can prove that the triangles are congruent, then we can show that any other piece or corresponding piece in the two triangles will also be congruent, because once you've shown it congruent with 3 pieces, then anything else that's in the triangle will also be congruent to its corresponding part. Because remember, congruent figures have exactly the same size and shape. So these are going to be the 2 steps, or the steps, in order to prove either 2 segments or 2 angles are congruent after you've proven 2 triangles are congruent. So once you've shown the 2 triangles are congruent, either using side angle side, which was the first one we learned, side side side, hypotenuse leg, angle side angle, or angle angle side, once we can show that they're congruent using one of the 5 shortcuts, then we can go back and find all the other corresponding parts are also congruent using corresponding parts of congruent triangles are congruent. This has an acronym. I'm going to take the C from the word corresponding. That's the first C here. Then the P from parts, that's the P here. Then the C from congruent, that's the next C. And then the T from triangles, that's the T. And then finally, last is going to be the last C, which is the word congruent, will be for the last C. If you notice in the acronym, every other letter is a C. C, P, C, T, C. And that stands for corresponding parts of congruent triangles are congruent. Let me go ahead and draw a picture to show you what I'm talking about. I'm going to draw a picture of 2 triangles. So let's say we have this blue one and a red one. And let's say I told you that this one is triangle ABC, and then this one will be DEF. And I'm going to give you enough congruency marks to show that these are congruent triangles. So let's say I gave you a congruency mark on angle C, and I told you C was congruent to F, and then AC congruent to DF, and then angle A congruent to angle D. What shortcut could I use to prove that these 2 triangles are congruent? Which one of these 5 up here could I use? Mateo?
Angle, side, angle.
Good. Angle, side, angle. So what I'm going to do here is I'm going to state that these are 2 congruent triangles using angle, side, angle. My congruency statement could be triangle ABC is congruent to triangle DEF, because notice angle A had the same marking as D, so that's why I put A and D in the first spot. And then E and B didn't have markings, so those are the 2 matches here, and they're the middle letters. And then C and F had the same markings, so that's why those were listed last. So this is the congruency statement. So now, by coming up with these 3 matches of corresponding parts being congruent, now any other side that doesn't have a mark or any other angle that doesn't have a congruency mark, I can now say is also congruent by using the CPCTC. You can write it in any order you want as long as all the angles match up. Okay, so she asked, could she write it as triangle ACB, absolutely, but then the DEF triangle, you would have to put it as DFE. So all of these need to match. The A and the D need to match, the C and the F need to match, and then lastly, the B and the E, absolutely. All right, now, the whole purpose of this CPCTC is, let's say I gave you all this information. Let's say the given was angle A congruent to angle F, angle A congruent to D, angle C congruent to angle F, and then AB or AC congruent to DF, and then you would say that yes, they are congruent using angle side angle. And then let's say what I wanted you to prove though was that BC is congruent to EF. So as soon as you establish that these two triangles are congruent, now you can say your last step would be BC congruent to EF because of corresponding parts of congruent triangles are congruent. So every other little piece now, this side now, BC will be congruent to EF. AB is going to be congruent to DE. So I could have changed the proof and said this instead. Every single piece that doesn't have a marking is now could be stated as being congruent. And then the last one, you could also say angle B was congruent to angle E, again, by corresponding parts of congruent triangles are congruent. Now, technically, if you start out by being given that you had two corresponding congruent angles in it, technically this one here, instead of saying CPCTC, I could also use that other theorem called the third angles theorem. So that's another way to do this if you're given that the other two pairs of angles are congruent. So the whole purpose of CPCTC is to identify all the other parts of corresponding parts that are congruent in the two triangles. So let's just do 3 proofs, and then you can start your homework. All right, so for my first proof, let me go ahead and set up my statements and my reasons. So statements and reasons. Go ahead and let's fill in all the given. So I was given that PR bisects angle QPS, and also that PQ is congruent to PS. I'm going to go ahead and add these congruency marks to my picture. So I'm given that PQ is congruent to PS, and I was also given that this angle QPS over here was bisected by PR. So I need to know what a bisector does, and a bisector is going to split angle PQ or QPS into 2 congruent pieces. So this is going to make that angle up top there congruent to the other one below, and that's going to be my next statement. So I'm going to state that that top angle QPR is congruent to angle SPR, and this reason is definition of an angle bisector. Now, notice what I was asked to prove. I was asked to prove that angle Q is congruent to angle S. I was not asked to prove the two triangles are congruent, but that's what I'm going to do first. So the two triangles that I'm going to show are congruent are going to be this top one that I'm going to highlight in blue, and I'm going to show that that is congruent to the green one here on the bottom. Notice I've already got 2 congruency marks. So now all I need to do is find a third one and then use one of the 5 shortcuts. Now, generally, whenever they're attached like this, the side that they share, that's going to be the obvious, and I can say that this side PR is congruent to itself because it's both the same side in both triangles. So I'm going to say that PR is congruent to PR, and this reason is reflexive. Now, what I was talking about pulling the pictures apart, if it's better for you to redraw the figure, and again, you guys could just trace over it with your notability. So here I could redraw the top one, and this is my P, Q, R, and this was the blue one. And then I've got the bottom one. And this is the PSR. And this is the one that I had highlighted in green. So I'm going to add back in the congruency marks so we could see that PQ was congruent to PS. And then we have this side congruent to this. And then we also have that bisected angle congruent to the other one. So now when you pull it apart, maybe it's a little bit easier to see that you've got a side and a side that match. And then you've got another side and then the included angle. So this would be, as you go around it, side, angle, side. So if it helps you to pull it apart, so maybe you can see that the reflexive side is the same on both, then it's easier to see. So my next statement is that congruency statement, and I'm going to state that QPR is congruent to triangle SPR, and that reason would be side, angle, side. Now, you could have listed it as RPQ, but then you would have had to reverse the SPR and put RPS. So again, the order that you list this statement, just as long as everything matches, doesn't matter. Okay, so then now I can actually do what I was asked to prove and show that angle Q is congruent to angle S. And notice in my statement, Q and S are the first letter. So because I have now stated that the blue and the green are congruent, now I can go back here and put congruency marks on all the remaining pieces. Q and S would be congruent. R and R, same letter, is the same. And then I could also add a congruency mark on that last missing side. So this proof could easily be changed throughout the day. And instead of me asking you to prove Q and S, I could have also asked you to tell me that that other side, that RS, was congruent to QR. Or that angle QRP was congruent to angle SRP. All of these could be determined from the original congruent triangle by using CPCTC. Any leftover corresponding part will also be congruent within a congruent triangle. So corresponding parts of congruent triangles are congruent. So these could have also been things to prove, and it would have the same reason as the reason in my proof for Q being congruent to S. The order between the definition of angle bisector and the reflexive step, you could have reversed these. You could have put reflexive as step number 2, and then the definition of angle bisector is step 3. You could switch the order on that. Let's try another one. Same thing. We're going to first have to establish that the triangles are congruent, and then we can use the CPCTC. What'll be challenging in the test is you're not going to know which of the 5 shortcuts to use. When you did the homework, it was easy because each lesson, that was the reason. If it was the SAS lesson, that was your reason. If it was the side lesson, then you knew that was going to be the reason in your proofs. Now, when it's all together, it could be any of the 5. Here we go. We got given, this time, PR is bisecting 2 angles. So let me go ahead and get the statements and the reasons set up. So statement number 1, let's list all this given. PR bisects angle QPS and angle QRS given. So let me go ahead and put this in my picture. So again, the 2 triangles I'm going to try to show are congruent. The blue top one and the green bottom one. And again, if you want to pull them apart, you can. So here is the angle, the first angle that's being bisected, the QPS, this one over here. And this is my bisector. So that tells me that it splits that angle into 2 congruent pieces. Then on the other side of the picture, I've got another angle that's bisected. So over here, QRS was also bisected, making these congruent angles. So now notice what we have here. I've got an angle and an angle marked as congruent in both triangles. I need to come up with another congruency, and that would be the obvious, and that's going to be this side that they share, and I can say that PR is congruent to PR. Now, I need to put all these congruencies into my proof. I can't just label the picture. So let's go ahead and do those bisectors first. So what we can put here is that angle QPR is congruent to angle SPR, and the other one, that was the pink, and then the purple was the QRP, is congruent to the SRP. So these were the pink ones. Oops, pink and purple. And this is definition of an angle bisector. And then the obvious one, the reflexive, PR, congruent to PR. Again, we could have put this second, doesn't have to be the third statement. It could be statement number 2, reflexive. And now we have enough information. We have ASA. So now I can state that the 2 triangles are congruent. So triangle QRP is congruent to triangle SRP, and this reason is angle side angle. Now, they wanted me to show that RQ, this side over here, is congruent to RS. So now that I've established that the blue and the green are 2 identical triangles, then now I can go back and say any other part that doesn't have a mark is also congruent, which was what they were asking me to prove, that RQ is congruent to RS using corresponding parts of congruent triangles are congruent. Every other letter is a C, CPCTC. Now remember, another thing that they could have asked me to prove instead of RQ congruent to RS, it could have been the other side. It could have been this PQ and PS. So instead of this, they could have said prove PQ congruent to PS. So that would have been my last statement with the same reason, CPCTC. Or they could have also said, prove that angle S is congruent to angle Q. And again, same reason. Or we could have also established the third angles theorem. So far here is my proof. I've set up the two columns, I filled in my given, and I've added in the congruency marks. So the two triangles I am going to try to show are congruent. Again, I'll highlight it in green and blue. And if it helps you to pull it apart, you could redraw them. Notice right now, I've got a side and a side that match, and then another side. So in both triangles, I've got two sides marked with corresponding congruent parts. What else could I pull in here to show that the green and the blue are congruent? What would be the third piece of congruency? Let's do that obvious, that side they share. I can state that ZX is congruent to itself. And now notice, I've got side, side, side. So my next statement will be that ZX, or you could put XZ, it doesn't matter, is congruent to itself. And this is reflexive. And now I've got enough information to state that triangle XWZ is congruent to triangle ZYX using side, side, side. And you may say, well, why is she doing this? I wasn't asked to prove that the triangles are congruent. I wanted to try to prove angle 1 is congruent to 2. But as soon as you can show that you have two congruent triangles, now I can go back and say any of those other three angles that are left have corresponding congruent parts. And I can use my statement as my match. So you can see that X and Z are going to match. And then from there, it would be the three letters. So here, I can now say that angle 1 is congruent to angle 2 by using my CPCTC. I could have also shown that angle W was congruent to angle Y. Now, if those numbers weren't in there, I would have to name these angles with three letters. Now, you may look at it and say, well, why couldn't I use alternate interior? I can't do that because my lines weren't given to me as parallel. The only way that you could have used that is if they would have given us that I had parallel lines in the picture. Now, let's say instead of them asking me to prove that 1 and 2 are congruent, let's say instead they said prove that WX is parallel to ZY. Soon as you establish that you have alternate interior angles, you can use your alternate interior angles converse to prove the lines parallel. So this process can come up with all different variations of what you're asked to prove. The proof could have also been prove W congruent to Y, or prove 3 congruent to 4. The last reason will still be the same, CPCTC. So that is it for section 5.7.